Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from origin to infinity. In this video, we are going to discuss a question of Csir-Net mathematics real analysis. But before that, let me share something with you. We believe that to qualify this exam, you just need to follow 3 simple steps: prepare, practice and perform. For more details, you can contact us from our website as well as on our WhatsApp number. Moving on to the question. The question is, if fx equals to x square sine 1 by x when x is not equals to 0 and 0 if x is equals to 0, then f is continuous at x equals to 0, f is differentiable at x equals to 0, fx is not continuous at x equals to 0, and option D, none of them. I recommend you to pause the video over here and first try this question by yourself and also go through the definition of continuity and differentiability at a particular point. Now let us solve this question. To solve this question, we will be using two results. The first one, if fx can be written as gx into hx, where limit x tends to 0, gx equals to 0 and hx is a bounded, then limit x tends to 0, fx will also be equals to 0. And the second one, f is said to be continuous if and only if limit x tends to c, fx equals to f c. These two results will be helpful to us in solving the given question. Now we can write fx equals to x square sine 1 upon x, where gx is x square and hx is sine 1 upon x. Clearly x tends to 0, gx will be equals to 0 and hx is a bounded function between -1 and 1 as it is a sine function. So limit x tends to 0, fx will be equals to 0 from the first result, and thus option A is true and f is continuous, and C and D are false. F is clearly continuous as the value of function at 0 is also given to us as 0 and limit is also 0. Now we just need to check whether the function is differentiable or not. Let us check it. For the differentiability, we find f dash x, which is equals to limit x tends to 0 fx minus f0 upon x minus 0, should exist. So here it will be limit x tends to 0 x square sine 1 upon x minus 0 upon x minus 0, which further simplifies to limit x tends to 0 x into sine 1 upon x. Again applying the same result, x tends to 0, limit is 0 and sine 1 upon x is bounded, so their product will again be equals to 0, and option B is correct, f is differentiable. Hence the answers are option A and option B. Thank you. Now one question for your practice. Find the limit x tends to 0 a raised to x minus 1 upon x. Options are A, 1, ln A and none of them. The solution of this question will be provided in the next video. Till that, you can be a member of our social club and watch 500 plus videos on our YouTube channel and get a complete study material for any higher mathematics competitive exam from our WhatsApp group.